Welcome back as we continue Chapter 12, and we are getting into the surface area of prisms and cylinders. So last section, we really just talked about recognizing what type of solid we are using or what's in front of us. So now we're going to focus more on prisms and cylinders today. And just to refresh your memory, if you've already learned some about these types of solids. First, starting with a prism. It's going to be a polyhedron with two congruent faces, also known as our bases, that lie in parallel planes. So if you notice at the left, I have put a few of these prisms up there. You can notice that the front, or the first base, is congruent with the back part of the base. So that is really what you need to be looking for when you're looking at these different solids. Do I have two congruent bases? If so, I'm going to label it as some type of prism. And normally what we talked about yesterday is you're going to name the front part of the prism by the base itself. So what is the base? If it's a pentagon, we're going to name it a pentagonal prism. So that would be a pentagonal prism. So how do we recognize the prism? Well, first it's going to be by the lateral faces. So these are going to be parallelograms formed by connecting the corresponding vertices of the bases. And we've talked before, normally those are going to be some type of rectangle that connects the two bases together. That will allow them to be on those parallel planes. And then the next are going to be the lateral edges. So these are segments connecting the corresponding vertices of the bases. So here at the left, I have kind of put a picture there that I had found online that really recognize the edges and the faces. So the lateral parts don't necessarily look at the bases, they just look at those parallelograms. Moving on to surface area, what we're going to talk a lot about today. To find it, we're just going to add up all the areas of the faces, or just adding up all the areas of all the sides that create our solid. And we will get more practice with that today. Next will be our lateral area, which is the sum of the areas of its lateral faces. So this will just exclude the bases. So it'll be the surface area minus the base area will give you your lateral areas. So you can write that down if you want to. So moving on to the next part is called a net. So a prism net or a cylinder net is going to be a two-dimensional representation of the faces of the polyhedron. So sometimes when they're 3D, it's really hard to kind of recognize all of the parts of this polyhedron. So I've kind of labeled the net as its skeleton. What is that shape or that solid created by? And here to the left, I've put a few different nets there, and there are a ton online that you can see. So it's almost just unfolding that 3D object and really seeing it in 2D. What is it made up of, or what are all the lateral faces and the bases? So that would be that, and we'll look at that a little bit more as well. And then just recognizing the difference between a right prism and an oblique prism. A right prism is going to be each lateral edge is perpendicular to both bases. So recognizing that if it's a right prism, kind of like a right triangle, we are looking for that perpendicular segment. And then an oblique, of course, is a prism with lateral edges that don't have that are not perpendicular to the bases. So it's almost like a right prism, but it's almost slanted. It's almost like how a parallelogram is to a rectangle, kind of that slanted shape. And notice that outside of the oblique, the height will be kind of what we have seen before in those parallelograms that are a little bit slanted, not necessarily a rectangle. And last we get to our cylinders, and I love cylinders because you can see them. I can recognize them all the time, and one of my favorite is that just a soup can is a cylinder. So a solid with congruent circular bases that lie in parallel planes. So you can tell that Campbell soup can, the top and the bottom are circular, they are circles, and they lie in parallel planes. And then to recognize a right cylinder, just the segments that join the center of the bases, so the center of both the top circle and the bottom circle, that segment that connects those are perpendicular to both bases. So that's how you can recognize a right cylinder. Moving on to our first theorem here of our section 2 is the surface area of a right prism. So using this for a right prism, the surface area S of a right prism is, so they say S times or equals 2 times the base area plus the perimeter times the height. And I have gone ahead and spelled it out for you in words because I am so much better with that. So again, 2 times the base area, only one of those, plus the perimeter of one of the bases times the height. Or you can say this also equals the apothem times the perimeter plus the perimeter times your height. So whatever you need to use, whichever one of those equations you can, they will work perfectly. So let's go and use that in our first example. So we want to find the surface area of the right prism. Alright, so each base is an equilateral triangle with a side length S, which would be 6. Using the formula for the area of an equilateral triangle, the base or the area of each base, and they have given us a new formula that we can go ahead and use. So 1/4 times the square root of 3 times the side squared. So we're going to use that to find the area of our base. So 1/4 times the square root of 3 times 6 squared would give us 9 square root of 3 inches squared. So that's the area of one of our bases. And the perimeter of each base, so I'm going to take 6 times 3, which would give me 18 inches. And the height, we know, is 8. So now we have our base, we have our perimeter, and we have our height. Those are the 3 things we need to put in our equation, so let's go ahead and plug them in. So 2 times 9 square root of 3 plus 18 times 8 would give us an approximate area of 175.18. So remember, we are in surface area, but we're still in area, so we still need to square those units. So you can go ahead and do checkpoint number 1. You can pause it and then go ahead and check your answer with mine. If you have any questions, feel free to ask later. And I will tell you that those your solids will get easier and easier to draw. So keep practicing, keep trying, don't give up from the very beginning. So our next theorem will be the surface of our right cylinder, which means the 2 centers of our bases are perpendicular through that segment that joins them. So this is the surface area equation we can use. So the surface area S of a right cylinder is 2 times the base plus the circumference of the base times the height. So I've again written it up top, or we can say 2 times our base area, of course, pi r squared because it's a circle, plus the circumference is 2 pi r times the height. Alrighty, so let's go ahead and use that. So we want to find the surface area of the right cylinder. So each base has a radius, and we can just look at that as 4 meters. You just look at that as just a normal circle. And the cylinder has a height of 5 meters right there. So now we're going to just plug in our equation. So 2 pi times our radius squared plus 2 pi times our radius times our height would give us 32 pi plus 40 pi, which is 72 pi, or approximately 226.19 square meters. Again, we are still in area, so we still have to square our units. So pretty straightforward stuff, just finding those values and plugging them into the equation. Go ahead and do checkpoint number 2. Again, keep practicing on drawing those solids. If you have any questions, you can ask when we come back to class. Alright, and last but not least, we want to find the height of the cylinder. So, and we know that the surface area is given to us, so we almost are going to plug it into the equation and work backwards, and we're going to substitute the values of the formula of our right cylinder and then solve for h. So we know that 2.8 is our radius, and we can plug that into the equation. So we are going to use this equation right here, our surface area of a right cylinder. So we know our surface area is 198.8 square millimeters equals 2 pi times, we know our radius is 2.8 squared, plus our circumference, 2 pi times our radius times our height, which is what we are solving for. So let's simplify. 198.8 equals 15.68 pi plus 5.6 pi times h. And notice that they are keeping that pi in there as long as possible because we've talked about it before, just making sure that it's as accurate. We can keep it in there as long as we can. So now we can subtract that 15.68 pi over. So we'll get 15.68 pi equals 5.6 pi h. We can simplify 149.54 is approximately 5.6 pi times h, and our height becomes approximately 8.5 millimeters. Again, we went through that pretty fast, but you can always go back and rewind and check. Go ahead and do checkpoint number 3. Don't forget to factor. Go through it algebraically like you normally would any problem and solve. And here is checkpoint number 3. Again, hope you enjoyed the lesson, and if you have any questions, feel free to ask when you come back to class, and I hope you have a great day. Thanks. Bye.